The accompanying joint probability table gives the proportion of individuals in the various ethnic group and blood group combinations. So, population has three ethnic groups, group 1, 2, 3. Belongs to four major blood group O, A, B, AB. The corresponding joint probability table is given. So, what is the meaning of this table? Means suppose this one 0.065, that is the probability of a person from ethnic group 3 and belongs to blood group B is 0.065. Suppose 0.141 means probability of a person from ethnic group 2 and having blood group A, that probability is 0.141. That way it is given. Meaning of the table is clear? Hello? Meaning of the table is clear?
Yes, sir.
Now, suppose that an individual is randomly selected from the population. Okay, an individual is randomly selected from the population and define events A. A is type A selected. B. B is type B selected. And C. C is ethnic group 3 selected. A is type A selected, B is type B selected, 3 is ethnic group 3 selected. Calculate PA, PC, P of A intersection C. So what is A? A is ethnic group, A is type A selected. So if type A selected, that person either from group 1 or group 2 or group 3. But they are mutually exclusive events. So probability of A 0.106 if he belongs to ethnic group 1, he is from ethnic group 1.141, group from 3.200. So P of A is 0.106 plus 0.141 plus 0.200. That is P of A. P of C. What is C? Ethnic group 3 selected. Group 3. So if we select group 3, person belongs to O blood group or A or B or AB. That's why 0.215 plus 0.200 plus 0.065 plus 0.020. That is P of C. What is P of A intersection C? A intersection means type A selected and from ethnic group 3. Type A selected means this column. From ethnic group 3 means this one 0.200. A intersection C. That will be probability will be 0.200. See here. That way it is calculated. So part A is okay. P of A, sum of these things 0.100, 0.141, 0.200. Yeah. P of C, sum of that row, third row, we are getting A intersection C, common portion 0.200. Part A is okay.
Yes, sir.
Then part B. Calculate both P of A intersection C and C intersection A. Explain in context what each of the probability represents. A intersection C and C intersection A, we have to find that probability. So P of so what is P of A intersection A given C? P of A given C is P of A intersection C divided by P of C by definition. P of A intersection C 0.200. P of C is 0.500. So we are getting 0.4. So what is the meaning of this? See, it is given that C. C means what? C is ethnic group 3 selected. So P of A given C 0.4 means if an individual belongs to, if an individual is select from ethnic group 3, then probability that he or she has a type A blood, that probability is 0.4. So here it is written, C happens. So if we know that individual came from ethnic group 3, that thing C. So if we know that individual came from ethnic group 3, the probability that he or she has type A blood, that is 0.4. C given A, similarly P of C intersection A by PA. So 0.200 by 0.447. So C given A, that means individual has type A blood. If a person has type A blood, then probability that he or she from ethnic group 3, that probability is 0.447. Part B is okay. Hello. Part B. Part B is okay.
Yes, sir.
Then part C. What is part C? If the selected individual does not have type B blood, what is the probability that he or she is from ethnic group 1? So we have not defined ethnic group 1. So if this selected individual does not have type B blood, so having type B blood even is B. So does not have type B blood means B dash. So B dash given. See the answer here. Sorry. Let define D equal to ethnic group 1 selected. So does not have type B blood. That means B dash. B dash is given. Then probability that he is from ethnic group 1. So D given B dash. So we have to find P of D given B dash. What will be that? P of D intersection B dash by P of B dash. So we have to find P of D intersection B dash and P of B dash. Now D intersection B dash. What is the meaning of that? D means ethnic group 1. D intersection B dash. B dash means outside B. So in this row, except 0.008. That will be D intersection B dash. So 0.082 plus 0.106 plus 0.004. That is P of D intersection B dash. That is done here. Then P of B dash. P of B dash is 1 minus P of B. Now 1 minus P of B, 1 minus sum of these 3, 0.008, 0.018, 0.065. 3.909. So required probability P of D intersection B dash by P of B dash. That way it is calculated. Then this is very very important, because when we will solve question related to tree diagram, it is required. For any events A and B with P of B greater than 0, so that P of A given B plus P of A dash given B equal to 1. So I am writing this very easy. Also it is done here. P of A given B plus P of A dash given B equal to 1. That we have to prove. It is given that P of B greater than 0. Why P of B greater than 0 is given? Otherwise we cannot define conditional probability. That thing is P of, by definition, probability of their intersection by whatever given P of B. This one same way, P of A dash intersection B by PB. Now this is P of A intersection B by P of B. This one. From B we are removing the A. This will be what?
P of B
P
minus
of,
P of A intersection B.
correct. P of B minus P of A intersection B. Now two term cancel, PB by PB. What is the value? Two term cancel, then PV by PV, that is 1. Only it is PV by PV. Remaining to cancel. So that's why it is 1. When we will write the T diagram, then these things are required. There may be another question here. We have discussed 56. Suppose 58. So that for any three events A, B and C with probability of C greater than 0, P of A union B given C is P of A given C, P of B given C minus P of A intersection B given C. Remember, what is P of A union B? PA plus PB minus P of A intersection B. Just conditional probability applied there. So that way you can remember. I am showing you the proof here. Somewhere it is written. P of A union B given C. So by definition, probability of their intersection. P of A union B intersection C divided by P of C. Then we are splitting this A intersection C union B intersection C. Okay. After that, union of two event PA plus PB minus P of A intersection B. So P of A intersection C plus P of B intersection C minus P of A intersection C intersection B intersection C. So first one P of A intersection C by PC, second one P of B intersection C by PC minus this one A intersection B intersection C by PC. This one will be P of A given C, next one P of B given C, next one minus P of A given B intersection C. That way it is done. Very simple proof. Then I will discuss this question. Not all part I will discuss. Question number 50. A department store sells sports shirts in three sizes: small, medium, and large. So a department store sells sports shirts in three sizes: small, medium, and large. Three patterns: plaid, print, and strip. And two sleeve lengths, long and short. So three sizes: small, medium, large. Three patterns: plaid, print, and strip. And two sleeve length, short sleeve length, and long sleeve length. So now the corresponding probability table is given. The accompanying table gives the proportion of shirts sold in the various category. So here table is given. Three sizes: short, small, medium, large. Then small, medium, large. Three patterns: plaid, print, strip. PL plaid, PR print, ST strip. Then two sleeve length, short and long. Probability table is given. What is the meaning of this? Suppose this point 1, 2. So a shirt is sold that is short sleeved, medium size, and strip that probability is 0.12. Suppose this 0.03. A shirt sold that probability that is short sleeve, large size, plate that probability is 0.03. Suppose here 0.05. That means a shirt sold that is long sleeved, printed, and medium size that probability is 0.05. That way table is given. Table is okay for all of you?
Yes.
Okay. Now, what is the probability that next shirt sold is a medium, long sleeve and print shirt? Medium. So here it is medium, here also medium. So either this row or this row. Medium, short sleeved. Sorry, medium, long sleeved. So long sleeved is here. So medium, long sleeved in this row only. Then printed. So medium, long sleeve printed. So value is 0.05. Is that okay? Part A.
Yes, sir.
Showing you something here in the solution. Some events are defined here. Sorry, it's getting hanged. So denote events. M for medium, sold shirt is medium, LS long sleeved, SS short sleeved, PR printed, PL plaid. LS long sleeved, SS short sleeved, M medium, PR printed, PL plaid. That way something is defined. So medium long sleeve printed 0.05. Am I audible? Hello?
Yes, sir.
Yes, sir, you are audible. Yes, sir.
Okay. Screen is visible or not?
Yes, sir.
Okay. Next is B. What is the probability that next shirt sold is a medium print shirt? So medium and print, but it is not mentioned short sleeved or long sleeved. So medium print, either it is from long sleeved or it is from short sleeved. So medium printed, medium here, printed here. So medium print, if it is long sleeved 0.07. Medium printed, if it is long sleeved 0.05. So short sleeved 0.07, long sleeved 0.05. So medium and printed either from short sleeved or from long sleeved. So 0.07 plus 0.05, that is 0.12. 0.07 plus 0.05, that is 0.12. Is that okay? B is okay, part B.
Yes, sir.
These type of questions may come. Okay. Then C. What is the probability that the next shirt sold is a short sleeve shirt? Another question, a long sleeve shirt. The probability that shirt sold is a short sleeve shirt. So size is not mentioned, pattern is also not mentioned. So it may be either short means small, medium, large or plaid print strip. So short sleeve probability will be 0.04, 0.02, 0.05 means sum of all these. Because size and pattern is not mentioned. So short sleeve probability will be sum of these probabilities. 0.04, 0.02, 0.05, 0.08, 0.07 plus 0.12, 0.03, 0.07, 0.08. That is done here. Short sleeved. Then long sleeved, what will be that? 1 minus probability of short sleeved, or you can add all those things. Since already short sleeved obtained, so for long sleeved it will be 1 minus probability of short sleeved. So 1 minus that thing. L is 1 minus P of S is also 1 minus 0.56. Then D. What is D? What is the probability that the next shirt sold is medium? So next only size is given medium, but no condition in pattern or sleeved. So size is medium, that means it will be either short sleeved or long sleeved. Pattern does not matter, it may be plaid, print or strip. So medium size, it will be only medium is mentioned, so 0.08 plus 0.07 plus 0.12. If it is for short sleeved and long sleeved, it is 0.10 plus 0.05 plus 0.07. So these three plus these 3. That is probability of SI is medium. That is done here. Then that the pattern of the next sold is print. So pattern is print. So size and slipped not mentioned. So printed 0.02 plus 0.07 plus 0.07 plus 0.02 plus 0.05 plus 0.02. So probability of a print next sold is print, that probability is this one. Section D is okay. Part D. Next two are related
Yes,
to conditional probability. Given that shirt just sold was a short-sleeved plate, what is the probability that its size was medium? So it is given shirt just sold was a short-sleeved and plate. So short-sleeved and plate means SS intersection PL. If you remember, short sleeve and plate, that is given. That means SS intersection PL is given. What is the probability that it is medium? So means we have to find P of M given SS intersection PL. So M given SS intersection PL. Now, so that is P of M intersection SS intersection PL divided by P of SS intersection PL. Then C, medium short sleeved plate. Someone mic is on. Whose mic is on? Sound is coming. Gaurav, mute yourself. Gaurav, mute yourself. Okay. So it was medium, short-sleeved and plate. Short-sleeved, medium, plate. So 0.08. That is here. Short-sleeved and plate. So short-sleeved, plate. 0.04 plus 0.08 plus 0.03. Here it is done. Then same way next part is done. Given that this shirt just sold was a medium and plate. Medium plate it is given. So M intersection PL. What is the probability that it was short sleeved or it was long sleeved? Two questions are there. Medium and plate that is given. So M intersection PL is given. Then probability of short sleeve. So SS given M intersection PL. SS given M intersection PL. Similarly, LS long sleeved, LS given M intersection PL. Just like earlier way, it is calculated. Okay, 54 is done. You go through it same way, same type of question. 58 we discussed. Then 59. I will discuss 59. What is 59? At a certain gas station, 40% of the customers use regular gas A1, 30% use plus gas A2, 25% use premium A3. So at a gas station, 40% of the customer use regular gas A1, 35% use plus gas A2, 25% use premium A3. See here, 40 plus 35, 75, 75 plus 25, 100. That means A1, A2, A3, they are mutually exclusive and exhaustive set of events. Total 100, so exhaustive. In fact, if a customer use regular gas, you will not use premium or plus. That's why A1, A2, A3 are mutually exclusive and exhaustive set of events. Is that okay? Is that okay? A1, A2, A3.
Yes, sir.
Now,
Okay.
of the customer, so what will be P of A1? 40% use regular gas, so P of A1 is 0.4. P of A2 0.35. P of A3 0.25. I am writing this. P of A1, so 40, 35, 25. P of A1 0.40, P of A2 0.35, P of A3 0.25. Now, of those customer using regular gas, only 30% fill their tanks. Event B. Actually, event B is fill their tanks. Of the customer using regular gas, 30% fill their tanks. So B is the event filling tank. Now, see here, of those customer using regular gas, only 30% fills their tanks. Fill their tanks. So who are using regular gas, among them 30% fill the tanks. That means P of B given A1 is 30.3. That means P of B given A1 is 0.3. Then of those customer using plus 60% fill their tanks, plus gas A2. So P of B given A2 is 0.6. Then P of B given A3. What is that? Whereas those using premium 50% fill the tank. So P of B given A3 is 0.5. Those things are given. Up to this okay? Hello? Up to this okay?
Yes, sir.
Now what we have to find? What is the probability that the next customer will request plus gas and fill the tank? So plus gas is A2. Fill the tank is B. So we have to find P of A2 intersection B. So P of A2 intersection B. What is that? By multiplication rule, P of A2 into P of B given A2. P of A2 is given, P of B given A2 is given. So that way you can find. So 0.35 into 0.6. That is P of A2 intersection B. Is that okay?
Yes, sir.
Now, what is the probability that next customer fill the tank? That means we have to find probability of B. That is first part. Probability of fills the tank, P of B. So it is not mentioned whether he is using plus gas, regular gas or premium. What is P of B? Total loss of probability. What will be that? P of B given A1 into PA1 plus P of B given A2 into P of A2 plus P of B given A3 into P of A3. All values are given, you put it. Is this okay?
Yes, sir.
Yes, sir.
So you will get some value. Then part 3. What is part 3? If the next customer fills the tank, so it is given the customer fills the tank. What is the probability that regular gas requested or plus gas requested or premium? So 3 questions are here. It is given fills the tank. That means B is given. So regular gas requested P of A1 given B. A1 given B. Which theorem you will apply? Bayes theorem. Correct or not? By Bayes theorem it will be P of A1 into P of B given A1 divided by P of B, means this sum. Or you can think this way also. P of A1 intersection B by P of B by conditional probability. But what is P of A1? P of A1 is PA1 into P of B given A1. PB, that formula is already obtained, so we are writing this. Basically, this is application of Bayes theorem. Similarly, A2 given B, A3 given B, you can calculate. Is this okay? Hello?
Yes, sir.
Okay. So here, by using tree diagram, it is. So what is tree diagram? See, A1, A2, A3. So 0.4, 0.3 corresponding probability are written. Then, so using regular gas, either fills the tank B or not. So it fills the tank P of B given A1, that is 0.3. So what will be P of B dash given A1? 1 minus P of B given A, that is 0.7. Then 60% use, so 0.6, here it is 0.4. 50% use here, 0.5, 0.5. That way. Okay, you go through it. So either you can do this way or whatever I have written, that way also you can do. Then before going to that, I am coming to one more question. I am first doing this. 63. For customer purchasing a refrigerator at a certain appliance store, A be the event that refrigerator was manufactured in US. So for customer purchasing a refrigerator at a certain appliance store, A be the event that refrigerator was manufactured in US. B be the event refrigerator had an ice maker. And C be the event customer purchased an extended warranty. So A, refrigerator manufactured in US. B, refrigerator had an ice maker. And C, customer purchased extended warranty. Relevant some probabilities are given. P of A, P of B given A, B given A dash. That way, how many are 1, 2, 3, 4, 5, 6, 7. 7 things are given. Construct a tree diagram consisting of first, second, and third generation branches, and place an event level and appropriate probability next to each branch. So we have to draw a tree diagram of first, second, and third generation branches. So basically 3 events are there, A, B, C. So that's why the first, second, and third generation branches, and place an event level and appropriate probability next to each branch. Now see how we have to draw that. So first generation it is A and B. So we'll start this way, either A or A dashed. Below this line we will write the event, and above we will write the corresponding probabilities. So P of A, P of A dash. After that, B occurs. So B may happen or B may not happen. B or B dash. Here also, sorry, not here. B and B dash. Then we will assigning probability. So here after this B, see when this B happens, already A is happen. So that's why here we will write that is basically B given A, means already A happen, assuming that we are finding probability of B. So this is nothing but P of B given A dash. Here we will assign P of B given A. Here it will be P of B dash given A. Here before B A dash happen, so P of B given A dash. Here it is P of B dash given A dash. Now tell me what is this sum? This plus this? 1 or not? Complement
Yes,
given?
sir.
1. So that's why not all values is given. So if P A is given, we can find P of A dash because sum is 1. Then third generation same way we will draw it. 2 branches. Here also 2 branches. Here also 2 branches. Here also 2 branches. Now, so here it is either C or C dashed. Either C or C dashed. C, C dashed. C, C dashed. Then we will assigning the probabilities. Before this, A and B are happen. So that will be here we will assign P of C given A intersection B. Here before C dashed, A and B happen, C dashed given A intersection B. For this C, A and B dash happen, so P of C given A and B dash. So A intersection B dashed. Here C dashed given A intersection B dashed. Similarly, here also we will write. That way, if we draw, that thing is called tree diagram. So writing tree diagram is okay? Hello? Writing tree diagram is okay? Reply.
Yes, sir.
Similarly, here we will write P of C given A dash and B. So A dash intersection B. Here C dash given A dash intersection B. Here also this plus this sum is 1. This plus this sum will be 1. This plus this sum will be 1. Okay, you can see it here in the notes. I have PA dash, B given A, B dash given A, then B given A dash. How to write that thing is written here. Now here, so total how many probabilities you have to assign? Sorry, 1, 2, 2 plus 4, 8, 8 plus 8, 2 plus 2 square plus 2 cube. So 2 plus 2 square, 4 plus 2 plus 4, 6, 6 plus 8, 14. But if you see here, 7 are given because by complementation rule we can find other 7. So construct a tree diagram for first, second and third generation branches. Place an even level appropriate probability next to each other. So P of A is 0.75. What will be P of A dash? 0.25. See here, A dash. Probability of A it was given 0.75. So A dash it will be 0.25. Whatever n circle that is not given in the table, that we are finding by the formula. All of these which is not n circle, that we are finding from the formula. Then it is given B given A and B given A dashed. So B given A, B given A. So here 0.9. B given A dashed 0.8. So B given A dashed B. So 0.8. Here it will be 0.2. Total sum will be 1. Here 0.9. Here it will be 0.1. Then any other if we think, suppose C given A dashed intersection B. Means A dashed and B happen, then C. So where we will write that probability 0.7, A dashed B C. A dashed B C 0.7. Then here 0.3. That way it is completed. So this part clear, part A. Hello.
Yes, sir.
Yes, sir.
In fact, now see part B, it was asked compute P of A intersection B intersection C. So what will be that? By multiplication rule, P of A, P of B given A, P of C given A intersection B. So it was given PA, P of B given A, P of C given A intersection B. PA, P of B given A, P of C given A intersection B. So using multiply those things, we will write that. That way it is written. But you can remember it different way also. See, A intersection B intersection C. So it is 3 generation. So 3 events are there. A, B, C. A, B, C happens where? A, B, C. So P of A intersection B intersection C will be 0.75 into 0.9 into 0.8. Suppose it is asked find P of A dashed intersection B intersection C. A dashed B C. A dashed intersection B intersection C. A dashed B C. So here. So 0.25 into 0.8 into 0.7. That way you can remember also. Suppose P of A intersection B dashed intersection C dashed. A, B dashed, C dashed. 0.75, 0.1 into 0.4. That is probability of A intersection B dashed intersection C dashed. That way you can remember. Is this okay? How to remember the thing?
Yes, sir.
Now, compute P of B intersection C. So here also B intersection C. So that is except first generation. So that includes either A or A dashed. So you can think B intersection C as B intersection C intersection A union A dashed. Because before that, that way you can split. But you can remember this way also. B intersection C we have to find. So means BC. B and C is here. BC dash not here. B dash C, BC dash not these things. Here BC, but BC dash, B dash C, B dash C dash. So B intersection C means here BC, before that A happened. Here BC, before that A dash happened. So that's why P of B intersection C will be P of A intersection B intersection C plus P of A dash intersection B intersection C. So A intersection B intersection C 0.75, 0.9 into 0.8 plus here 0.25 into 0.8 into 0.7. That way you can remember. Are you getting the point? BC. So before that A happened, here A dash happened. So 0.25, 0.75 into 0.9 into 0.8. So ABC. A dash BC 0.25, 0.8, 0.7. That way you can think. Here already A intersection B intersection is in the calculated in first one, so not written. Is that okay? P of B intersection C? Hello? Similarly, P of C. How
Yes,
we can
sir.
find P of C? So C happens where? Here C. So up to that we will here C, here, then here, then here. So for this contribution is 0.7, 0.9, 0.8. For this C contribution 0.75 plus into 0.1 into 0.6. Plus for this C 0.25, 0.8, 0.7. plus for this C 0.25, 0.2, 0.3. That will be P of C. Or you can write this way also. Same thing actually. So if you remember the trick, then there is no chance of mistake. Then compute P of A given B intersection C. That will be P of A intersection B intersection C divided by P of B intersection C. That is calculated from the table. You see it. Next is, if A and B are independent, then A B dashed, A dashed B, A dashed B dashed. So what are the pairs including A and B? Means considering complement, A B one pair, A dashed B, A dashed B, A dashed B, sorry, A B dashed, A B dashed and A dashed B dashed. Now if anyone is independent, any one pair is independent, then others also independent. Okay. If AB is independent, then this independent, this independent, this independent. If A dash B independent, then AB independent, AB dash independent, A dash B dash independent. So if at least one is pair is independent, then others also independent. That is the result. Next one. Statement is okay? Hello? Statement is okay?
Yes, sir.
So what is the proof? A and B are independent. So P of A intersection B is PA into PB due to independent. We use that one. So A and B dash independent we have to show. So A and B dash independent means we have to show P of A intersection B dash is PA into PB dashed. PA into PB dashed. So then by the formula A intersection B dash P of A minus P of A intersection B. P of A intersection B due to independent PA into PB. PA minus PA into PB. PA common, PA into 1 minus PB. 1 minus PB is PB dashed. So PA into PB dashed. We are starting from P of A intersection B dashed. We are getting PA into PB dashed. So A and B dashed are independent. Similarly, same way A dash intersection B. You see it? Then A dash B dashed are independent. So we have to show P of A dash intersection B dashed is PA dashed into PB dashed. Now De Morgan's rule applied. A dash intersection B dashed is A union B dashed. Then by complementation 1 minus P of A union B. So P of union B formula PA plus PB minus P of A intersection B. That we have put. Again due to independent P of A intersection B is PA into PB. Then this is 1 minus PA into 1 minus PB. First one is PA dashed, second one is PB dashed. That way it is done. You go through the things. Okay. And these are, so if A and B are independent, others pair also independent, sometimes they are directly we will use that result. So this part okay? This question? Hello?
Yes, sir.
'71. This is due to last question was on independent 71. So independent means P of A intersection B is PA into PB, or P of A given B is PA, or P of B given A is PB. An oil exploration company currently has 2 active projects. So one in Asia and other in Europe. So an oil exploration company has 2 projects, one in Asia and other in Europe. Let A be the event that Asian project is successful and B be the event that European project is successful. A is Asian project successful, B is European project successful. Suppose A and B are independent. So it is A Asian project successful, B European project successful. A and B are independent, that is also given. Also it is given P of A is 0.4, P of B 0.7. So P of A 0.4, P of B 0.7 and A and B are independent. Now we have to find some probabilities. If the Asian project is not successful, what is the probability that European project is also not successful? If Asian project is not successful, so Asian project successful A, not successful A dash. So A dash given. We have to find P of B dash given A dash, because also European project not successful. We have to find P of B dash given A dash. So it is given A and B are independent. So that's why A dash B dash also independent. We can use that result. See, if A and B are independent, then A dash B dash also independent. So we have to find P of B dash given A dash. Since independent, P of B dash given A dash will be P of B dash. What is P of B dash? 1 minus PB. PB is 0.7, so it is 0.3. Is this part okay?
Yes, sir.
Or by definition, you can find it also. P of B dash given A dash is P of B dash intersection A dash by P of A dash. That way also you can do. But somewhere you have to use that one. P of A intersection B is P A into PB. Now, what is the probability that at least one of the two projects will be successful? So at least one of the two projects successful. That means A union B probability we have to find. So what is P of A union B? P of A union B is PA plus PB minus P of A intersection B. A intersection B value not given, but due to independent, P of A intersection B is PA into PB. 0.4, 0.7 minus 0.4 into 0.7. That way it is done. Then part C. Given that at least one of the two projects successful, what is the probability that only Asian project successful? Given that at least one of the two projects successful, means A union B given. What is the probability that only Asian project successful? That means Asian project successful, European project not successful. So A intersection B dashed. So we have to find P of A intersection B dashed given A union B. Conditional probability formula, then values are put here. That way it is done. Remaining questions 78, 80, maybe this one I will not discuss. So next class we will discuss these questions.
Okay, sir.
These are very, very important. And one thing, when you are free, I want to take one class. Anytime free, when tomorrow or today. Are you free
So
sometime?
tomorrow you have a class, na?
Tomorrow we have a class. So except tomorrow, maybe Friday. I forgot your timetable. Just wait. This course is how many are attending the class? Okay, I will. Why it is not opening? Uh, For all of you in laptop, same thing happen. Means slow or not? My laptop is very slow.
Yes, sir.
Sorry. Third section wise. Your is Acha. We have class 10 to 11. Can I take today 1 to 2?
No, sir, please not today.
Then give me some day that day I will take.
Say
Tomorrow
in the
already.
evening maybe. So after 8 to 9 or something like that.
Okay, no, someday I will take.
Okay, sir.
Okay, sir.
So attendance.
Attendance I will 76. Already 9 over. Any I will give all of you.